Fractions. I'm Jack Faley, your K-5 math supervisor.
And I'm Rebecca Ode, the district resource teacher for math.
So, Rebecca, do you have up your classroom fraction number line yet?
I do not know what this is, and no one told me to put this up, so no.
What? Oh my gosh. All right. Well, if you are teaching a grade that involves the instruction of fractions, you should have up a classroom fraction number line, especially when getting into equivalence. As you can see here, this classroom fraction number line is huge. It actually spans from one door to the other outside in the hallway.
Wow.
And these little post-it notes that are on here are a great way to show students how different fractions that are equivalent occupy the same space on the number line. This number line goes from 0 to 1, but you can have your number line go even greater than 1. That's excellent because it allows then for fractions greater than 1, mixed numbers. You can even go back to earlier in the school year when we were talking to our kids about decimal fractions, and our decimal fractions can occupy the same space on the number line too.
Well, that's a great idea.
In this grade level, let's check out what's different. We know that our kids worked a lot on fractions last year in 3rd grade. Rebecca, what do you notice that is different between 3rd and 4th grade?
So it looks like in 3rd grade they were identifying equivalent fractions, and now they need to generate equivalent fractions.
Yeah, they've got that new verb in there, right? So they are actually going to be generating those. I don't know why I said
Okay.
We're going to move to the next slide. What we'd like you to do here is just take a moment, and if you're on your own, this is a reflection question. If you're collaborating with a group of teachers, just pause the video and have a brief discussion. So with many students in the past, instruction on equivalent fractions focused around the phrase, whatever you do to the top, you do to the bottom. Did you ever hear that?
I may have said that, actually, if we're being
Rebecca,
honest.
Okay, I did too, if I'm being honest. And we use that phrase to help students remember the process to generate equivalent fractions, either multiplying or dividing the top or, there's my quotes, the top or the bottom of the fraction to get that equivalent fraction. So what we'd like you to discuss with your group or to just reflect upon, what do you think about instruction that focused upon using this phrase to remember this process? In 4th grade, the standard calls for our students, just like they did in 3rd grade, to use manipulatives, pictures, and number lines before then heading into the abstract and using equations when they're generating equivalent fractions. So when the standard says we're going to generate equivalent fractions, students can break out their manipulatives to generate those fractions. And as they're doing that, you can see here some examples using fraction circles. But what we want students to do is also to notate underneath each of their pictures or underneath each of their manipulatives, what does that fraction look like when we write it with the numerator and the denominator? And start to notice trends, start to notice patterns that they see. As I break that fraction into smaller pieces, what happens to the numerator and what happens to the denominator? Helping students see those patterns is going to really help them understand the equivalency.
So students will start to understand why the numerator and denominator, the same thing happens once they use their models instead of a rule.
You're catching on. Yes, that is exactly right. We want them to understand, not just memorize that little phrase, right?
Makes sense.
One thing to think about when using number lines, in many resources and in many classrooms that I've seen, each time as we are taking the different fractions and showing them and showing whether they are equivalent or not, we use a different number line to show, say, halves, and then when we're doing fourths, there's another number line, and if we were going to then do eighths, there'd be another number line. Rather than doing this, which can sometimes not make the message clear that these fractions are equivalent, we want to focus just on one number line and go ahead and take those values, the fourths that we had on that second number line, and just add them to the same number line. As the students see them occupying the same space, they start understanding, oh, okay, these have the same value.
I love that idea, because I know that usually my students get confused when they see different denominators of fractions on the same number line. So that's a great idea.
Yeah, and as they start adding to it, I mean, sometimes the number lines can get a little messy. You remember that classroom number line that had like a ton of Post-its all stacked on one half? That's okay. It helps students to see, man, it's getting cramped here because we have so many ways that we can say the value 1/2.
Totally.
So as our students move from concrete to pictorial to abstract, we want them to really understand what does it mean to be equivalent, and how do we generate those equivalent fractions. Students will start to see patterns, and they'll start to see that if I multiply the numerator and the denominator by the same number, I will generate an equivalent fraction. But that seems kind of weird to kids, and it kind of sounds weird to me as an adult. How do we just multiply a number by some value and it stays the same? I thought when we multiplied number, I mean, I always learned in 3rd grade,
Yep.
right? When we multiply a number by
Value
another
gets
number,
bigger.
it doesn't give me the same number, does it? Oh, wait. It does.
With fractions.
Well, and it does with whole numbers if I multiply by
1.
Yeah. So if I multiply by 1, that'll give me the same number, but here I'm multiplying by 2. So this seems kind of odd. But if you take a look, are we really multiplying by 2? I think you said it.
We're multiplying by 1.
We're multiplying by 1 because 2 over 2, or 2/2, is the same thing as 1 whole. So we really want our students to understand they're not multiplying by 2, they're multiplying by a fraction equivalent to 1 whole. And in this case that you see here, they're multiplying by 2/2. One of the things that students will be challenged with during this unit is they're going to be asked to change fractions with the denominator of 10 into an equivalent fraction with the denominator of 100. When they do that, they're looking at something like this. So let's say I have 8/10 and I want it to be some type of equivalent fraction with a denominator of 100. If I think back as a student to my place value understandings, I know that as I move up and down the place value chart, I'm either looking at things being 10 times greater or 10 times less. And so if I'm thinking about jumping from 10 to 100, I should be able to use my knowledge of place value and understand that I'm going to be looking at either trying to make this 10 times greater or 10 times less. In this situation, of course, it's 10 times greater, right?
Right.
So I'm going to multiply the denominator by 10. And if I think about that equal sign, I know that I'm trying to create an equivalent fraction. So if I multiply 10 by 10 and get 100, I want this to be equivalent, and I know I can't just multiply by 10. So even though I'm saying I'm multiplying the denominator by 10, I'm actually multiplying that whole fraction
By 1 whole.
Yes, that's it. You got it. So we really want to nail that down with our students and help them to understand, yes, we are multiplying the numerator and the denominator by 10, but we're actually multiplying the whole fraction, 8/10, by 10/10, which is 1 whole. Okay, and you can see that, of course, that gives us 80/100. All right, so just to recap, thinking about our islands of the concrete, representational, and abstract, our CRA method, we want to make sure that we are building that understanding through all of those different islands, not just jumping straight to the abstract thinking and saying, hey, whatever you do to the top,
You do to the bottom.
yeah, they'll just know that. We won't have to have them repeat it a bunch of times in order to figure it out.
Totally.
All right, everybody, thank you. We hope that you enjoyed Unit 4. We'll see you at the next Math Dive in 5.